here, this is something else I wanted to get into. This is a capacitor bank operation. Capacitor banks essentially open and close. The open and close response is a half cycle event, as you can see here, and it's typically called a ring wave event. Now, this can cause a lot of zero crossing errors, a lot of issues with logic, VFDs, PLCs, but it does cause a direct fault on the customer side. So the customer's equipment is seeing this fault due to a utility operation that happens several times a day. This over time will cause damage if not treated and mitigated properly at your facility. Now, this essentially, some utilities, very few, they have what's called a zero closing switch. This means that the distortion is caused by the operation of the equipment not happening at a zero flux, essentially. So let's say our A phase, red here, this would mean that this would open or close at zero. C phase would open and close at zero, and B phase would open and close at zero. Well, this doesn't happen. The open and close, you can see here, this was almost at the peak of the positive flux on B phase, and so with A phase. Now that is what causes the distortion, is, depending on how high or negative the flux is when it opens and closes. Now you'll see similar distortion, maybe not a ring wave or such, but you see distortion and faults caused by utility operations, your LTCs, your regulator banks, everything causes sinusoidal distortion. One other thing I wanted to speak on is to our system planners. As I mentioned earlier, in our scenario, red feed would feed up to the first recloser if the fault was seen here. So your fuse coordination, it's all fault current based, fault current being provided from the substation or the source. So if you change your source and the path to the fault, your impedance in your line, you may not have enough fault current to blow the fuse. So let's say this fuse is coordinated with green feed normally. Well, your distance to your substation will be 1 based off of green feed. Your distance to the fuse and available fault current will be another once it's switched around. You can run into a lot of issues, especially if you have longer feeders. Some of our customers down south, you look at Florida, we've seen 1,000 times where a line would fall in an orange grove or something where it's very sandy. Line will just sit there because there's not enough available fault current, distance to the substation, distance to source, to actually blow the fuse. So a hot energized line will actually melt the sand, create an insulator, and that sand will actually form glass around the conductor, and it'll just sit there alive because there's not enough fault current at the end of the line. Once you start changing your configuration like this, and however many times they change, it's a nightmare to coordinate. APQ, we do training for our system planning engineers on how to coordinate properly, how to set your reclosers. We kind of bring up a lot of these concerns with our engineers that we work with. I'm not saying self-healing teams are bad. It's great in a lot of scenarios if they're done properly. That's the thing. A lot of utilities do this to save money and possibly present to the PSC saying, hey, we reduced our outage duration, our customer outage duration. What can we get in terms of a rate increase? Well, yeah, that might look good, but what is the voltage levels that you're providing to these customers during these 2 minutes or a minute of operations? You know, what kind of transients are you sending to the customers? Have you even done a survey to ask the customers on that team, is this something that you would be wanting to have your utility provide to you? You know, some customers may say, you know, an hour outage is the same to me as a minute outage. It doesn't matter. I'm going to go on generator backup. It's just all these transients that you produce to me is causing me damage. It's causing me downtime because, you know, your typical generator ramp up time is 10 seconds. So asking your customers as a utility, is this something you even want before we go spending a lot of money on it and a lot of issues? But guys, without getting too far into it, I just wanted to touch on what a self-healing team is, some issues behind it, and some items to think of. If you have any questions, feel free to reach out to us. We'll be more than glad to answer any questions you got or even work with your utility in designing some of these for you in your area. But yeah, thanks for tuning in, guys. Catch you next time.